On assignments, let's see if it's an optional quiz grade, which I offer periodically. So having another 100 in your quiz average is really helpful, unless you have all 100s, but still. Obviously, my goal is that you should be fast at this. Also, you can find lots of good practice under my topics. If you look under topics, there's lots of good practice on finding trig values. I'll click through some of those in just a minute. I kind of clicked through them earlier, but I probably did it too fast at the end of class where everybody was leaving. All right, so the computer's really slow right now. Obviously, I don't know if okay, here we go. All right, so the clock is ticking. 2 pi over 3. Katie's really good at this, so it's right here. 3 pi over 4. What quadrant? You're just going like this. Second. All right, pi over 3.
First.
I was just testing y'all. Pi over 3 should have been 60 degrees, right? Pi over 3 is bigger. All right, 5 pi over 3, what quadrant? Third quadrant. I'm sorry, third or fourth? Fourth. It's really close to 6 pi over 3, but it didn't quite make it. 2 pi over 3. These are going to be all my pi over 3s up there. 180. The one I clicked a little while ago. Pi over 2. 30-degree angle. Okay. 7 pi over 4. 4 pi over 3. Right past 3 pi over 3, 60 degrees. 2 pi. 3 pi over 2. 7 pi over 6. 5 pi over 4. 5 pi over 6 didn't quite make it to 6 pi over 6. Pi over 3. 3 pi over 4. Pi over 4. Ah, we didn't make it to a minute. But anyway, you can. All right? So let's do it faster. Are y'all thinking along with me?
Yeah.
It's hard to say that.
Yeah, you can't really say where, just be thinking. Okay, and again, that was at a somewhat leisurely pace, and Nicole did it in 30. So anyway, you've got until, oh, did I say today?
Next Friday.
Next Friday. Did I really? Gosh, that's way too nice of me. Okay. So now let's look at topics page together. Oh yeah, Friday, October 25th. Look at that. All right, so now we're going to go to topics, and I'm going to show you some things that can help you as we head toward the test. There's going to be other things that help you also. I'll pull up some of these today, in fact, when I'm doing something else, but hopefully I've named them to where it'll help you. Interactive practice problems. Practice, you probably don't want to, well, you might want to do this. So you might want to practice sine, cosine, tangent, cosecant, secant, and cotangent, because we haven't done these really yet over here, okay? I want to do both. You can set how long you want it to be. Can y'all see where my cursor is? Timer, you could have a timer or no timer. Doesn't matter to me. Cosecant is 60. Does anybody know what that would be? Sine of 60 square root of 3 over 2. So cosecant of 60 would be 2 over square root of 3. And do you see how it keeps a record of right and wrong up there? So you can see how you're doing. It's great practice. Cosine of 0 is 1. Cosine of 0 is x over r, so it's 1. Okay? And anyway, so that's good practice. So then you can also go to this. Practice trig values. And this is really cool. Like you're thinking in your head. Like sine of 0 is 0, and then you can click show so that you can see if you got it right. Do y'all see what I mean? So you can kind of think through these, all right? Like say I just wanted to test myself on the tan of 120. I'm thinking in my head that should be negative root 3. And then you can just click it. It's like little virtual flashcards. So that's really good. I think this might be that angle game that we were just playing. And that might be it, but that's good. It's good stuff. Okay, and then there'll be more coming. Here's the unit circle if you want to look at it. There it is. Okay, so now we're going to talk about homework from last night, which is all that's happened with this. You're just, hope you did your homework. You know, if you want to be like, get your homework grade, especially some of you that may not have all 100 homework grades, but even if you do and you want like that added buffer, I'm not going to run around and check it right now, but if you want, as we're leaving for lunch, you know, if you want to go, oh, here's my homework, I'll be glad to give you a grade for it, okay? It won't count against you if you don't do that. I'm just ready to move on today. So it's your lucky day if you didn't do your homework, but I already know y'all well enough to where I think everybody probably did their homework. Hopefully you have some intelligent questions about that, and we'll come to that in just a minute. I wanted to talk about this. There are points on the unit circle for these values. Not just those two. I could stand here and list lots and lots of values. And that's like, may pull it up in the book, but those are questions in the book that I'm not quite sure I've given you those explicitly. But I've talked about it off and on very quickly at the end of class. I just wanted to let you know, because I always want you well versed on what other people are doing too, so that you're, oh, okay, I got that. Even if you could choose to do it that way, or if you don't choose to do it that way, at least you know what's happening. So as I move around, not my best friend, the unit circle, okay? In this case, the radius is 1. And every time I mention it, though, I notice a couple of my students say the radius is 1 when I'm not even talking about the unit circle. So it can grab all of us. The radius does not have to be 1. The reason they use a unit circle is because numbers like this in your old geometry 30, 60, 90 triangle, which, by the way, if you're in degrees, you got to always write degrees. If this is 4, then this is 8, and the sine of 30 is 4 over 8, which is 1/2. So do you see on the unit circle, they'll all reduce down to sine of 30 will be 1/2 and so on. So they're actually, like if this was a XY axis, when I turn 30 degrees, do you see there's an actual point there that we're talking about? Okay. So I don't want all of that there, though. Let me undo.
What if we 4 root 3?
Not if I'm doing sine of 30.
Oh.
I'm sorry, I was talking about this one over here, if I was talking about sine of 30. I haven't done these yet.
No, I know.
Sine of 30,
Yeah, because like 4 over 8.
opposite over adjacent.
Oh, so I thought that was the.
Now, I think I just confused you, but you okay now?
Yeah, I thought
Sine
you
of-
were just writing down the length of the other side. And I was like, why is it
I just never even wrote down the length of the other side. It would be this. Okay. Now what you did, and I'm going to come to you just a second, Isabel. This actually was one day going to become the radius of a circle, right? An angle is really just part of a bigger circle. And so what they've said, well, if this is 1, then this side is 1/2, and this side is root 3 over 2. Square root of 3 times the short side, which again, not a big fan of. I just need to do this and then I'll take your question. If the radius is 1, right here at 30 degrees, if the radius is 1, okay, then this side is 1/2, And then you multiply this by square root of 3, and you get square root of 3 over 2. And so you get the actual numbers that are in your chart. Like, I guess what I'm trying to say, do you see they're already in reduced form? But what can be confusing is sine is really your y coordinate of that. If my radius is 1, this coordinate is 1/2, and this x coordinate is square root of 3 over 2. If I go up here at 45 degrees, that point is root 2 over 2, root 2 over 2, if you think about that. My radius is 1, and then you divide this side by root 2 and this side by root 2. 1 over root 2. Doesn't that become square root of 2 over 2? And then at 60 degrees, they flip like we talked about with our cofunctions, and we end up with we end up with 1/2 and square root of 3 over 2. Up here, this is really easy. This one would be 0, 1. So the thing that's a little confusing about this is we tend to go sine, cosine, tangent, and a lot of our minds think of sine in the front. But if we're going to do it as points, do y'all realize x is in the front? So this is cosine, and this is sine. In case you're working with somebody that does that. Because cosine is x over r, x over the radius of 1. Sine is y over r, so it meshes with what you're learning, but I find that people get kind of confused, and then it's hard to go back and forth. But that's what you see along some other people that are carrying around a unit circle like you carry around your memory page. And over here, as I get these points, we'll have some positives and negatives as I go around. So y'all see what I mean? So that's why some people use a unit circle, is you're just putting like 1/2 over 1, the square root of 3 over 2 over 1, and you're getting a fully reduced number. To me, it doesn't matter at all. Those numbers are going to happen in both my circles. Oh, question.
Oh, which is when I was doing the homework, I was like still kind of confused on when my calculator should be on reading and degree mode for like numbers like 101 and like the last few. The last 4, I had no idea.
If you see this, say this is number 4 on your test on October 30th. That's radians. That's 30 radians. You can have 30 radians. You can have 30 degrees. You can have, hang on just a minute. You can have 1 radian. Radians don't have to have pi in them. I could have this. I could have the sine of pi degrees. That would be about 3.14 degrees. It would be very, very tiny. You know you're in radians in the absence of a degree circle. You know you're in radians if there's no degree circle. It doesn't have to have pi in it. Girls, pi is just 3.14. It's just a number like 7. Okay? You can have 70 radians. You could have 70 degrees. That's why it's really important that we speak the correct language, and that if you mean degrees, I'll count off if you don't put the circle there. And if I don't put the circle there, I'm not in degrees. I'm in radians.
Yeah, but what if there's in the textbook you had some that had it was like sign like parentheses and some that didn't have parentheses? Is there
Let me look
difference?
at it. All right, so 289, I believe.
Yeah, because when I was looking at the answers and what I got, it like kind of had to do with like whether you calculated it.
Oh, absolutely. There's one number. Did I give you all of them or odds and evens? Okay. Call them out, Lily.
93, 97, 90, and 101.
All right, 93 was, well, that one was pretty apparent. Tangent of 245. By the way, before I even look back at this book, usually they're in parentheses if they've got a negative,
Yeah, they are.
because they don't want you to think I'm saying tangent of negative 200 minus 200. Like, usually they're in parentheses, so you see the angle's negative. So you don't read it as a minus sign. That's usually why those are in parentheses. That should be a non-issue. The parentheses don't matter what mode you're in at all, okay? How did I know that this was in degrees? It has a degree circle. I can easily have 245 radians. It would be a ginormous wrap around the circle, but definitely things turn at a speed of 245 radians per second or whatever, okay? So now I'm going to go to 97. 97 was the secant of negative 280 degrees. I would type that into my calculator as 1 over cosine of negative 280. And am I in degrees or radians? Degrees. 101 was the cosecant of negative 8 pi over 9. Why is that in radians? No. Why is it in radians? Obviously, I'm talking extremely sternly now because of misconceptions people have that we should not have, that I know you have right now. Okay, so I'm being really stern because you don't want to mess this up. That is not in radians because it has a pi in it. Why is that in radians? The absence of a degree circle. If I'm in degrees, what am I going to have to write on there? Degrees. So if on your test you see this, the sine of 48 pi degrees. And that, why would that be in parentheses? Not because it's telling you the mode, just so you want to know what the degree circle applies to, right? Is it 48 times pi degrees? Is it 48 pi degrees? Pi's just a number. Pi doesn't even have anything to do with an angle. But once a pre-cal teacher teaches that, all of a sudden everybody's brain maybe shifts over, mine included, did also. That's why I'm being so animated about this. Is it so weird? But couldn't you get out a ruler and go 3.14 inches? Pi is not unique to angles, okay? Why do we use pi so much? Because unbeknownst to us, beyond our control, the super cool things happen in radians. Is 3 radians is a very inconvenient place. Where's pi radians? It's at 180 degrees. Okay, that's only because I counted 3.14 of something. Pi has nothing to do with angles. Pi is a number like 7 or 5 or 38. Isn't it? What's pi? 3.14? You've seen it a lot before I ever taught you this, right? It's just a size. Is 30 always degrees? Couldn't I have 30 inches? Couldn't I drive 30 miles? So don't get hung up on pi, okay? If pi's in there, you might most likely have radians maybe, but not necessarily. All right, so if you see this, radians or degrees? Radians. Probably wouldn't be in parentheses. Usually parentheses is to capture something like a negative or more than one statement. So the parentheses don't matter. They're not trying to tell you anything. Certainly I assigned those to you because I expected some confusion and I wanted to have this discussion. I know it almost sounds like as animated as them of us. You're probably like, wow, she's really mad at us or she's fussing at us or something. I'm not. It's like we have every year got to push past this. It's so common. You know, the first year I taught it, I'm like, oh yeah, I thought the same thing. I didn't know what mode I was supposed to be in. It's so easy. It's just the absence of a degree circle. You're in radians. Nobody made up a little symbol like they did for feet, inches, centimeters, whatever. It's just radians, okay? I would type it into my calculator like this. 1 over the sine of negative 8 pi over 9. Let's do that. Okay, good question. Hang on just a second. Oh, by the way, have your calculators out for where we need to go next. Okay. Girls, I'm checking my mode. Here's another thing that I see my students in a panic over. You're like, I've spent my whole life not ever worried about what mode I'm in. And all of a sudden I'm in pre-calculus. I'm a little scared of what mode, because she's now taught me 2 languages, okay? The only time it matters, if these three buttons. If you're gonna push plus or minus or times or something, if you have 5 radians minus 4 radians, or 5 degrees minus 4 degrees, you're still gonna get 1 or whatever that is you're talking about. Do you see that it only matters? 1 degree is vastly different from 1 radian if you wanna find the opposite of the hypotenuse. So it only matters what mode you're in, we're gonna push those 3 buttons. Okay? Because now you're entering trigonometry. So what I'm going to do now is I'm going to work cosecant of negative 8 pi over 9. I'm in radians. I check my mode. I'm going to say 1 over sine of negative 8. The pi button's right here. Second, I can't even see it. Pi over 9. And then everybody should have negative 2.924. Questions? Lindsay?
So when you have no degree sign, you have to put the calculator in
If it's not in degrees, it is in radians. Yeah, if there's no degree circle, what mode are you in?
then you have to put it in the
Or you'll get it wrong. Okay? How will you know you're in degrees? Not because it says 180, because it's got a degree circle. Okay?
So like, this is more for like generally like for the test on this, like
Girls, listen to each other, and we've still got a super important thing to do in 10 minutes. So move along.
Will there be like a no calculator section?
Oh,
Because
yeah.
then that's like only like this type of stuff, right?
Yes.
Okay.
Okay, so let's look at this. You have your calculators out, please. And just look on with Lily, okay? I'm going to be calling on you to give me values, and we need to move fast, so you don't need to talk to your neighbor, okay? Even if you're sharing a calculator with your neighbor. By the way, don't run the risk of not having your calculator in the room. Make sure you have it with you, okay? All right, so moving on in our slides. Let's see, we've already seen this one. Let's go to another one. So here's Grace. And if you notice, this is the Instagram thing I told you about that I got from that former student. I've been out of college for nearly 2 years, and I still have this. Grace wasn't holding you in the picture, but I gave it to Grace. So that was Jessica's memo page. All right, so now we are going to this. All right, now, after all of that big, ginormous speech, where you're looking at, like, who took Mrs. Airy and put this woman in her place? I'm sure y'all are like, why is she so crazy about radians and degrees? Because I don't want you to miss it, all right? I want you to get it right. And it's confusing. That fully is not anymore. How easy is that? If it's got a degree circle on it, you're in degrees. And guess what I wanted all of these to be? I wanted those to be degrees, but right now, what are they? Radians. So if you'll all put this, I just didn't go through my little worksheet and put all of these in there. But if you'll go to degrees, because I'm going to be calling you by name to give me the degrees. Ready? So make sure you're with me. So we're going to fill in this chart, okay? I'm going to tell you what to do. I'm going to start with Michaela. Sine of 0. Okay, thank you. All right, Katie Hall, sine of 30. Okay, and by the way, you can give me decimals for this. Lauren, sine of 45. Okay, Pietra, sine of 60.
0.866.
Okay, thank you. All right, Zaina, sine of 90. I'm not writing down 1/2 square. I did write 1/2. I'm not writing down square root of 3 over 2, square root of 2 right now because I'm about to graph. And you're not going to have any idea what square root of 2 over 2 is. However, let's talk about an idea of how I even knew it was 0.7, okay? Square root of 2 is about 1.414 just because I'm a huge math nerd, and I know that 1.414 divided by 2 is about 0.7. I'm figuring you don't know that, therefore I'm writing decimals so that when I start graphing, you'll know what I'm doing, okay? Because if I said I'm going to go out 45 degrees and go up square root of 2 over 2, wouldn't we then need to get it in decimal to know how far to go up? So I'm doing it as I go along, okay? So I'm just writing my fractions in decimals because I'm not sure you would know where square root of 3 over 2 was. That make sense? Okay. So let's move on. Let's see. Chloe, sine of 120.
0.866.
Okay. Rebecca, sine of 135.
0.7.
Okay. Did you punch it in or did you just know?
It's 45.
Thank you. Okay. Sine of 150, Elena.
0.5.
Okay. Sine of 180, birthday girl.
0.
Thank you. Sine of 210, Grace Murray. Okay. Sine of 225, Lindsay. All right, Brianna, sine of 240.
-0.87.
Okay. Danielle, sine of 270.
-1.
Okay. Lily, sine of 300.
-0.87.
All right. Kayla Pola, sine of 315. Okay. Mary, sine of 330.
-0.13.
Okay, that can't be right. Try it again. Sine of 330.
Oh, I've been reading.
Okay, great though. Yeah. I planted her in the audience just for that. Okay, for us to learn that lesson. Katie, did you just know that? Sine, because it's a 30-degree reference angle in the fourth quadrant. Or are you watching the pattern?
Yeah.
Okay. Sine of 330, everybody. 0. All right. Sorry, 360. Okay, so now I'm going to graph these. Okay. So I'm going to go 30, 60, 90, and these are degrees. 120, 150, 180, 210, 240, 270, 300, 330, 360. All right, now, girls, looks like most people are talking about what they see on the board, but just watch. Does everybody see in the chart that we did tons of numbers, but they never got very big? These numbers are what I call captured. They're contained, which is a real important part about sine and cosine. The highest number I see in my chart is 1. The lowest number I see in my chart is -1, so I spread it out some so I'd have room to graph all these fractions. Sine of 0 is 0. Sine of 30 is 0.5. Sine of 45 is 0.7, and that's right in between these two. Sine of 60 is 0.87. Sine of 90 is 1. I'm just connecting the dots. Sine of 120 is 0.9. Sine of 135 is 0.7, which would be right in between these. And sine of 150 is 1/2. Sine of 180 is 0. Kind of missed my dots, but I think you get the point. I think everybody knows this is going to happen because then it's negative. Look how literal this is about all students take calculus. All students, sine. Is this what sine does? All students take calculus. Is that what sine does? I just unwrapped this circle that was going around like this, and it's like if anybody's ever how to spool a ribbon. I could have one here, and when you pull it up, do you see it starts to look like this? I could take a slinky that you usually have in here, and I could stretch it out, and all that was just going around like this. You can actually see it going around in a different way, stretched out over time. Okay, now this is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Do y'all see what I mean?
Yeah.
It just keeps going 1, 2, 3, 4, 1, 2, 3, 4. So why did I stop at 360? What's going to happen if I go further? Okay, so really this graph goes on and on forever, and if I had time, I should extend it and draw it. That's called, I just drew a period of that graph. I'll go through all the words with you. What you'll do over the weekend is you'll do a discovery worksheet that starts off like this, that I will attach to the assignment. And then you'll also try, there'll probably be a short video to watch to do a separate worksheet. A couple comes from one that I want to move into, okay? So I'll post all of that later. And a practice memo class, not a real one. But I'll put all of that up for you. Oh yeah, let me turn off QuickTime.